Hi, good day, hello, and how are you? So, we're looking at a more in-depth idea about forces, motion, and so forth. So, in this series, we're going to look at momentum, forces, and how to draw forces diagram. Let's jump right in. In this series on forces and motion, we're going to look at weight, gravity, and stretching. For forces and motion, we're going to look at what is the difference between mass and weight as one of the objective questions. Second objective question, describe how the resultant force can change the motion of a body. Objective question 3, calculate the resultant of two or more forces acting along the same line. And objective question number 4 is, what is the effect of friction, air resistance, or drag on a moving object? So first we have to go through our keywords. Our keywords are force, Newton, air resistance, friction, drag, solid friction, and resultant force. What is force? Force is the application of a push or pull to change the movement of an object. Newton is not just the man who discovered most of the physics ideas related to motion, but we also measure force in Newton. Thirdly, air resistance. Air resistance is the force of air that goes against the motion that we're trying to create. Fourth, friction. Friction is the contact force that is stopping us from moving forward. So it is any non-flat surface that's creating a counter force when you are trying to move. Then the fifth one is drag. Drag is similar to air resistance, and we usually talk about drag in liquids or in air where we are not touching the ground. So drag refers to the drag of a liquid on the motion of a body, or it can be the drag of air that is flowing over a car or over a plane that is not touching the ground. So if your car is airborne, it means that there can be some drag force on it. Then we have solid friction. Solid friction means it is in contact, it is touching, so it is solidly on the ground. And last one is resultant force. Resultant force refers to the force that is left over or calculated based on two different forces that work in the x-axis and the y-axis. So here we have forces, motion, and acceleration. How do unbalanced forces change or affect motion? If a force is unbalanced, it means it is accelerating and it is experiencing a push or pull force. So I'm going to jump into the whiteboard and then explain that. So welcome to my whiteboard. When you have an unbalanced force, it means the net total of the forces is not zero. So when we draw this, we will create a direction like this and also a direction in this direction. And if we say that the left-hand side is 20 newtons and the other side is 5 newtons, it means that it's not balanced if this is your object. So when you have a 20 newtons on the left-hand side and 5 newtons towards the right-hand side, it means your object will be moving to the left-hand side because it is not balanced. Whereas a balanced force will look more like this, where you have the object once again, and you have 5 newtons in one direction and 5 newtons in the other direction, which means that they're equal. The object cannot be split in two, so it is staying in one place. In the next one, which forces are considered important? So we have a list. So we have a list of forces which are important, and these forces will affect the motion of an object. For example, we have friction, we have applied force, we have normal force, we have drag force, and so forth. So when you are drawing a forces diagram, you have to think about all of these different types of forces that are considered important. So I'm going to make an X and a Y table that shows you where each force can be found. All right, so first we have the Y-axis and the X-axis and the resultant. Alright, so an easy way to remember these ones is the y-axis is force of gravity And this is not talking about the acceleration that's pulling it down. This is weight. We also call it weight. All right, weight. The next one you can consider in the y-axis will be drag force or air resistance. And then in your x-axis, you will have contact force. In the y-axis, you also have your contact force, also known as your normal force. And this is the force that's going straight up. So if you're in contact with the ground, it's the one that's going straight upwards from what you're doing. So if you're sitting and watching this video, it means your weight is pulling you down and your normal contact force is direct and opposite because you're not falling through your chair. You're sitting on it or sitting on your bed or wherever. And then in your x-axis, you will have your drag force. You will have your friction force. Okay. You'll have your friction force, or you can call it solid friction, and you can have your applied force. As you can see, I also drew a diagonal line, and on this diagonal line, we have forces that are a combination between the two. So it's a combination of the one and the other. That means when you're on the resultant force or the angled force, you will have force applied, you will have normal force, but remember, normal force is always 90 degrees, and I still don't know how to make that sign. You will have weight, and you will have friction. And this friction can be air resistance or it can be solid friction. It's usually solid friction as well. Okay, so friction in this case will be solid friction and also air resistance, depending on your question. So as you can see, this breaks down the different forces that you have to put in your forces diagram. And that is something we're going to practice next. Remember, in your x-axis, you can also add upthrust. Upthrust is in liquids. So upthrust is only found in liquids. So if you're in a liquid floating around, it means that the pressure of the water body pushing you upwards. This is the upthrust that we talk about. So that was that for this part of our motion and forces section. I really hope you enjoyed it and that you have time to go and look at the different links that I shared with you during this video. Enjoy your day.